All right, so today we are going to be working on Chapter 6, Lesson 1. We're going to be talking about solving inequalities by addition and subtraction. So we're going to learn how to solve linear inequalities by using addition, and we're going to solve linear inequalities by using subtraction as well. Some vocabulary to keep in mind is set builder notation. And so this is just a specific way they're going to be writing the solutions. So how are inequalities used to describe school sports? In the year 1999-2000 school year, more high schools offered girls track and field than girls volleyball. So if 20 schools added girls track and field and 20 schools added girls volleyball the next school year, there would still be more schools offering girls track and volleyball than schools offering girls volleyball. See, if you have 14,587, that's going to be more than 13,426. And if you add 20 to each one, this amount will still be greater than this amount. And so basically that's just saying if you have two quantities and one is bigger than the other, if you add the same amount to both of them, that one will still be bigger than the other. Okay, and this is going to kind of lead us into our main ideas here. So solving inequalities by addition. It says recall the statements with greater than, right, the greater than symbol, less than, the less than symbol, greater than or equal to, right, that's that little line underneath means it's greater than or equal to, or less than or equal to. Same thing, a less than sign with a line underneath means it could be less than or equal to. Those are known as inequalities. The sports application illustrates the addition property of equality, so the example that we just talked about. So the key concept here is that if any number is added to each side of a true inequality, the resulting inequality is also true. So really it's kind of similar to our addition and subtraction properties of equalities with equations. Inequalities kind of work the same way. If you add the same thing to both sides, then it will remain true, right? So if two things are equal and you add the same thing to both sides, they're both equal. Well, in inequalities references, if one side is greater than the other side or less than the other side, that will continue to stay true if you add the same thing to both sides. So here's an illustration of where we talk about that. If we say that 2 is less than 7, if we add 6 to both sides of the inequality, that means that we have 8 on this side and 13 on this side. The left side is still less than the right side because we added the same thing. This inequality, the symbol stays true. And so this is what we're going to use to solve our inequalities. Let's look at an example. If I have t minus 45 is less than or equal to 13, what I want to find out is, well, what does t have to be in order to make this work, right? And we're going to treat this just like if it were an equation. We're going to solve it by getting the variable all by itself. So we have t minus 45 is less than or equal to 13. So I want to get the t all by itself. I want to isolate the variable. Well, I got to get rid of subtracting 45. How do you do that? Adding 45, right? If I add 45 to both sides to make sure I keep the inequality true, that's going to leave me with t is less than or equal to 13 plus 45 is 58. So that means that t can be any number that's less than or equal to 58 in order to make this true. So as long as if I pick 58, it'll be here. 58 minus 45 is going to be equal to 13. And if I pick any number that's less than 58, it'll make a number that's less than 13. So we can check this by substituting. So we can substitute a number less than 58, and we can substitute it by putting a number greater than 58 to test to see if it works. So we let t be exactly 58, right? If we plug 58 in for t, that's going to make it that 13 is equal to 13, which would make this statement true. Well, if we let t be something less than 58, right, like 50, and we plug it in, so 50 minus 45 is 5. Is 5 less than or equal to 13? That is true. 5 is less than 13. And then let's pick a number greater than 58. So let's pick 60. If I put 60 in, 60 minus 45 is 15. 15 is not less than or equal to 13. So clearly, I can't pick a number greater than 15. So this would prove to me that I can pick any value for t, right? T can be any number that is less than or equal to 58. We know that when it equals 58, it works. When it's less than 58, it works. But if it's greater than 58, it doesn't work. So there are an infinite number of solutions that would be essentially any number that's equal to 58 or less than 58. So the solution set is all the numbers that are less than or equal to 58. So the solution of an inequality was expressed as a set. All right. A more concise way of writing a solution set is by using set builder notation. The solution in set builder notation would look like this. And basically these funny symbols here, well, you probably recognize this answer right here, but it's kind of has braces around it, and it's got the T and a line here. And basically the way that you interpret this is this just says for all T's in this problem, T must be less than or equal to 58. That's how you would read set builder notation. We can also use this to express it on a number line. So here I have a number line, and basically this blue highlighted section represents all the numbers that T can be. So I have a closed filled in circle here on 58 because it can equal 58, and I highlight everything less than 58 with an arrow at the end representing that it can go off into infinity or negative infinity in this direction. So any numbers that are greater than 58 are not highlighted because those don't work as a solution. So a number line is another way that we're going to be expressing answers. So just how to read it, right? It's set as all numbers T such that T is less than equal to 58. So that's how you would read that. But the real important part is just making sure that you have this part of the solution right here. So graphing the solution. So if I say, hey, solve 7 is less than x minus 4, then graph it on a number line. Well, again, if we're solving it, our goal is to isolate the variable, get the variable by itself. So I'm going to start off by getting rid of this minus 4 here. So I'm going to go ahead and add 4 to both sides. So when I add 4 to both sides, it leaves me with x on this side. 7 plus 4 is 11. So here, remember that the inequality symbols, right? The bigger side is always like it's like an alligator mouth, right? It's always eating the bigger thing. So it's saying that x is greater than 11. And I know this is kind of written in a weird direction, but it still means the same thing. X is greater than 11, or 11 is less than x, right? So again, we can write it either in this direction or we can write it in this direction. And if you notice, when I switch the direction of the inequality, I have to switch the direction of the inequality symbol. These two mean the same thing though. So again, my solution set is that for all x's have to be greater than 11. And then this would be my number line. So again, I would put a open circle at 11 because it does not include 11. It cannot equal 11, right? There's no line under the inequality symbol. So since it cannot equal 11, I have an open empty dot. And then it says x is greater than 11. All the numbers greater than 11 go to the right, right? All these numbers are bigger than 11. So let's look at solving inequalities by subtraction. So solving by subtraction is just like solving by addition. So same thing, if I have like 17 is greater than 8, if I subtract the same thing from both sides, then I would get 12 is greater than 3, right? The left side is still greater than the right side. That does not change. So this property is true when it's greater than and less than, or greater than or equal to, or less than or equal to, right? So let's look at example number 3. Solve 19 plus r is greater than or equal to 16, then graph the solution. So again, I want to isolate the variable. So I'm going to start by subtracting 19 from each side. And I would get r is greater than or equal to negative 3. So now I have my solution. So now I have to graph it on a number line. So here's my number line. It's going to equal negative 3, right? Because it's got the line underneath. So it's a closed circle. And then r is greater than negative 3, which is all the numbers to the right. But this terms with variables can also be subtracted from each side to solve inequalities. So let's solve with a variable on both sides. So I have 5p plus 7 is greater than 6p. So we're going to solve it and then graph the solution. So I have to get the variable. Right now it's on both sides. I want to get it on one side. So I can start by getting rid of the 5p on this side. So I just have to subtract by 5p on both sides. So 5p minus 5p makes 0. So it leaves me with just the 7. And then 6p minus 5p is just p. So I have 7 is greater than p, or p is less than 7, right? So I could write it like this. These two things mean the same thing. And so here's my answer. So graphing it on a number line would look like this. So it would be an open circle on 7 because it cannot equal 7. It has to be less than 7. And all the numbers less than 7 go to the left. So I would highlight in that direction. So verbal problems containing phrases like greater than or less than can often be solved by using inequalities. The following chart shows some of the other phrases that indicate inequalities. So you might see these in story problems or word problems that we do in context. Right? The less than symbol is usually represented by a less than or fewer than. The greater than symbol is represented by greater than or more than. The less than or equal to is usually we'll see at most or no more than or less than or equal to, right? The greater than or equal to symbol would be at least or no less than or greater than or equal to. So look for these key phrases when you're trying to write an inequality. So let's look at an example. Write and solve an inequality. So it says write an inequality for the sentence below, then solve the inequality. 4 times a number is no more than 3 times that number plus 8. So 4 times a number. So how do you represent a number you don't know? With a variable, right? So 4 times a number is no more than 3 times a number plus 8. So it would look something like this. 4 times a number, right? 4 times n is some number, is no more than, so this quantity cannot be more than, so that means it has to be smaller or equal to. And then it says 3 times a number, so 3 times that number, 3 times n, plus 8. So this would be my inequality. So again, I'm going to solve by getting the variable on one side. So I'm going to subtract 3n from both sides. And that would give me n is less than or equal to 8. So if you notice, a lot of these strategies are really identical to when we were working with equations, but now we're working with inequalities. So here's the solution set, right? For all n's, n must be less than or equal to 8. So basically, any number will work as long as it is a number that is equal to 8 or less than 8. And let's look at the last example. Write an inequality to solve a problem. So it says Yulia Rezkina scored a total of 39.548 points in the 4 events of the rhythmic gymnastics. Yulia Bruskova scored 9.883 in the rope competition, 9.900 in the hoop competition, and 9.916 in the ball competition. How many points did Barskova need to score in the ribbon competition to surpass Ruskina and win the gold medal? So let's look. So if we examine the words, it says Burskova's total must be greater than Ruskina's total. We're going to let R be Burskova's score in the ribbon competition. So let's look at her total, right? So Burskova's total has to be 9.883 plus 9.900 plus 9.916, right? The 3 scores she already gotten, plus the score of her ribbon score. And it has to be greater than, if she wants to win the gold, over Ruskina's total, which is 39.548. That was her total. So she needs to score, whatever she scores must make this total greater than this total. So now we can solve the inequality. So again, I'm going to start off by simplifying this. I'm going to add these 3 values together. And so if I add these together, it's going to add up to 29.699. And so the final part is getting the variable by itself. So I'm going to subtract 29.699 from each side. And that's going to give me that R has to be greater than 9.849. So this would tell me that she has to score at more than 9.849 in order to win. Because if she goes at equal, they'll tie. So that would give me the answer to this problem, right? She needs to get 9.849 points to win the gold medal. All right, thank you guys for watching. Let me know if you guys have any questions.